In this video, I'm going to go over homework number, for Applied Calculus class, Math 261, homework 3.2, number 1. All right, let's open it up. Oh, it's a multi-parts problem. Okay, so it says for the following function a, give the coordinate of any critical point. So I'll start with those, okay? So let me turn on my notepad so that I can write some work. Maybe I can. Okay. So critical points. I need to find the first derivative. So when h of x is 2x cubed minus 24x, then the first derivative, h prime of x, is 6x squared minus 24. Critical values happen when the derivative is equal to 0. So I set this equal to 0. And then I'll solve for x. Oh, Luna. Factor out the x. I will get x squared minus 4. Look how nice. I'm going to zoom in for you. X squared minus 4 can be factored as x plus 2 times x minus 2. Then, two critical values are x equals negative 2 and positive 2. I want to find their y coordinates, so what I will do is I will plug in these values into the original h of x. H of x, well, h of negative 2, first of all, is, notice I'm plugging it into the original function, not the derivative, because I want their y values. 2 times negative 2 to the third power minus 24 times negative 2. And what is that? I typed that into Desmo's scientific calculator and got the value to be 32. Just like that, let's now find h of 2. 2 times 2 cubed minus 24 times positive 2. And that is negative 32 this time. So I have two critical points. Negative 2, 32, and 2, negative 32. What I now need to do is to check, oh, where did my homework go? Hold on, I may have, oh, it's hiding right here. I now need to see if these are either relative minimum or relative maximum or neither. So how do we do that? I'm going to use the second derivative test. Okay, so what you do is you now find the second derivative. Looking at the first derivative up here, the second derivative is h double prime of x is 12x. And oh, well, that's it, right? Because I'm going to get 12x from that term, and derivative of this number, constant 24, is just 0. So that was simple, hey. So now I need to plug in my critical values in here so that I can see their sign. H double prime of negative 2 is negative 24. All right. Remember from from our lecture videos that if you get a negative second derivative, because this number is negative, negative 232, or 32 is the relative maximum. I'm now going to check h double prime of positive 2. If I plug in positive 2 into the second derivative, I will get positive 24, and positive second derivative means negative 32. This guy right there is a relative the minimum. All good. So now what I'm going to do is I'm going to go to my math lab and then I will type these answers, okay? So it says, what are the coordinates of the relative extrema? Select and the choice below, and if necessary, fill in the box. Okay. Relative minimum points are, let me see my note. Relative minimum is 2, -32, and relative maximum point is -2, 32. I am done with this problem. Actually, with part 1. I'll click on check answer. Of course, they're gonna say excellent. Yay. Okay. Let's go to part 2. It says, on which interval is h increasing or decreasing? All right. And now we did all the hard work. So I'm just going to use this to find the increasing and decreasing interval. Okay, if I can find my Apple Pencil. Where did I just put it? Oh, it's right here. All right, hold on. So building on to what we have so far, I'm going to sketch a quick picture, okay? So, a quick picture. I will plot -2, 32. I'm sorry, the screen is so small. I wonder if you can see this. It's 7:30 in the morning. Okay. So -2, 2 to the left, 32. Let's just say that's 32, okay? That is the relative maxima. So to make this a maximum, what the graph should look like is this. It's gonna look, oh, whoopsie, that's a little too thick. Hold on one second. To make this a maximum, the graph should look something like this. Do you agree? I don't like the width of this graph. It should look something like this. That's a relative maxima. Now the other relative extremum was 2 to the right, down 32. 2 to the right, down 32. I'll just say this is -32. But this point right here is a relative minima, which means the graph should look something like this. And I'm just going to connect them, okay? I'll just connect these dots here. And I have a beautiful picture where I can just read the increasing and decreasing interval. I can clearly see this graph is going down from my relative maximum to relative minimum. So it's decreasing on -2. You see that is -2 to, this point right there is +2, +2. So it's decreasing on this interval. On this interval right here is decreasing. It's going down from left to right. Now, how about increasing? Increasing on, first of all, it's going up from left to right, from -infinity to -2, union. The second increasing interval is from 2 to +infinity. 2 to +infinity. So I have my answer. I'm now going to type this in my math lab. All right, let me lower the screen. Increasing on -infinity. How do I type in the infinity symbol? Oh, it's right here. -infinity to -2, union 2 to +infinity. And it's decreasing on in between -2 and +2. And I will click on check answer. Oh no, what did I do wrong? It may be something that I didn't type in correctly. Hey, increasing on. I don't know what I did wrong. Well, I'll click on check answer one more time. Well, oh, maybe they never wanted the union symbol. You see how I put a U here? Maybe they never wanted the union symbol. They said use a comma. So it's just, okay, so I'll get rid of the U and I'll put a comma here, okay? And let me see if they're gonna take this time. Check answer. Fantastic. Awesome. So, okay, you should not be using a union symbol. Sorry, just type in comma. All right, part number 3. What are the coordinates of the point, inflection points? So for inflection point, I need to do the second derivative, set it equal to 0 and check the signs to the left and sign to the right. Okay, so let me see. I got my notepad ready. Bless you. Bless you, Luna. So what I will do is I will find the second derivative. Look, the second derivative was h double prime of x equals 12x. To find the point of inflection, you will need to set this equal to 0. When is 12x equal to 0? When x is equal to 0. So, x equals 0 is a potential point of inflection. And I say potential because I'm not going to say 0 is a point of inflection or x coordinate unless I can actually see the signs to the left and signs to the right. So what I will do is I will plug in a number to the right of 0. What is h double prime of 1? H double prime of 1 is 12 times 1, which is a positive 12. So this area is concave up. Interval to the left of 0, I can plug in negative 1. If I plug in negative 1 into the second derivative, I will get 12 times negative 1, which is negative 12. That means interval to the left of 0 is concave down. Oh, I write too big. Concave down. So because the concavity to the left and right of 0 are different, 0 is the x-coordinate of the point of inflection. Now I need to find the y-coordinate of this point of inflection. So let me go up and see what h of x was, because I now need to plug in 0 into h of x, okay? Because I'm just finding the y-coordinate. So if I plug in 0 in here, don't touch that. No, Luna, hold on. Mommy almost done. All right, I'm plugging in 0 into h of x. And this one is easy, huh? It just comes out to be 0. So the point of inflection is at the origin, 0, 0. So let me type that in. And you notice, I think the next question is going to ask for concavity. Is concave down to the left of 0, concave up to the right of 0. So over here, point of inflection is 0, 0. Check answer. And okay, they're asking for concave up. Remember, it was concave up to the right of 0. So I'll say from 0 to, let me zoom in so that you can see. Oh, I might have to type this infinity in first. So it is concave up on 0 to infinity, and it is concave down on negative infinity to 0. That's what I'm going to type now. Negative infinity to 0. And I will zoom out and check answer. And excellent. I am done with this. I'm sorry. Now we need to graph now. So which of these functions is decreasing? Well, I need to first see which point has 2, negative 32, negative 232 plotted. And in fact, don't I have a graph already, a sketch of it? So let me show you real quick how I sketched this already. over here. So I'm looking for a graph that looks like this. First one somewhat. Second one is definitely no, right? The second one is flipped. So B is incorrect. A may be it. C is no. And D could be it. So what I need to do is I have to actually click on it. But I remember that we have a point of inflection at 0, 0. So I need a graph that goes through 0, 0. I can see A is like that. A goes through 0, 0. Point of inflection, obviously, I can see is concave up to the right side of 0, concave down to the left side of 0, increasing from negative infinity to negative 2, and 2 to positive infinity, and obviously decreasing from negative 2 to positive 2. I love graph A. I think A is the answer. I'm going to click on A and check answer. I work very slow, so it took me about 16 minutes to do a single problem. But I hope this was helpful. I will come back and do a number 2 in another video. But the work that I did for number 1 looks like this. Just wanted to show this to you before I end the recording. So, da-da-da-da-da. There you go. Okay, let me hit pause the recording and process this video on YouTube for you.